Today we are going to do experiment on Kirchhoff's laws. The circuit diagram is here. There are 5 resistances: 100 ohms, 27 ohms, 220 ohms, 33 ohms and 82 ohms. I have mounted them on the breadboard. The first step is to measure the resistance values and note in the table. I am setting my DMM to ohm meter position. I am going to measure the resistances one by one. The zero error of the meter is 2.5 ohms. I am measuring the resistance across each resistor. I have noted the values of the measured resistances here. I have hooked up this circuit on the breadboard. Observe here 100 ohms, 27 ohms and 220 ohms are connected to a common point like this, and the other end of 220 ohms, 33 ohms and 82 ohms are connected together at one point like this. You have two power supplies in the circuit, 5 volts and 10 volts. Negative of 10 volts goes to 27 ohms resistance here like this, and the positive of the 10 volts power supply is connected to one end of 33 ohms. This is the point. You have the other power supply, 5 volts, connected between these two ends. We are using these two power supplies. You're going to get constant 5 volts across these two ends, and I have set 10 volts on this power supply. 10 volt supply is connected across these two ends and 5 volts is connected across these two ends. Connecting the power supply, we are going to make our DMM into voltmeter. Now I am going to measure the voltages across each of the resistors. This is my R1, R2, R3, R4 and R5. Voltage across R1 is here. It shows 5.7 volts. I am going to note it. This is voltage across R2. It reads 2.17 volts. I am going to note it. This is voltage across R3. It reads 5.27 volts. This is voltage across R4. It reads 4.57 volts. This is voltage across R5. It reads 2.60 volts. I have noted all the values in this column voltage drops. I am going to change this voltmeter into a meter by connecting the positive end here and by clicking on the ampere DC position. Now it's reading milliampere DC. Now I have to measure the current flowing through R1, R2, R4, R5 and also R3. Now for measuring the current flowing through R1, I have to break the circuit at R1. This end is positive. I am connecting positive of my ammeter here. Negative of my ammeter goes here. It reads 52.75 milliamperes. For measuring the current flowing through I2, I am removing it from this point and connecting the negative of my DMM here. Positive of the ammeter goes here. The current is 72.59 milliamperes. I am going to connect the circuit back to its original position. Current through R4, negative I have pulled out. I am connecting negative of my multimeter. Positive of the multimeter goes here. The current is 52.75 milliamperes. Now I am connecting the circuit back. Now I'm going to measure the current flowing in R5. I have pulled out at this point. I'm connecting positive of my DMM here. Negative of my DMM goes here. It shows a current of 72.62 milliamperes. Now you see I'm going to measure the current flowing in branch R3. The current is flowing in this direction because the power supply E2 is more powerful than E1. It is supplying 10 volts and E1 is supplying 5 volts. Therefore, the current from E2 flows through this, through R5, and it will have power to flow through the resistor R3 in this direction. Now I am going to measure the current flowing in R3 branch. The current is assumed to flow from this node upward. This end is positive, this end is negative. Positive of the ammeter should be connected to this end and negative of the ammeter should go to the common node B. Now I am going to measure the current flowing in R3. I have to pull out from this end. I have pulled out the resistor and I have placed it at a different point here. Now I am going to connect the ammeter between these two ends. Positive of the ammeter here, negative of the ammeter here. Now positive of my ammeter is connected to that point and negative of the ammeter goes to the common node B. The current is 22.28 milliamperes. I have recorded the currents in this column. You see current I1 and I4 are the same because they are flowing in the same branch. Currents I2 and I5 are the same because they are flowing in the same branch. Keeping the ammeter connection as it is, we are going to adjust the power supply E2 so that the current in this branch is 0. Now I am going to reduce the voltage at the 10 volt source so that the current reaches 0 milliamperes for me. So I just keep going. Yeah. I'll stop at this point. I think. Now see the current in the milliammeter reads 0.003 milliamperes. The supply is around 1.6 volts. I have noted the voltage of the supply E2 here, 1.6. I am going to pull out the ammeter from this position and I am going to put the circuit back to its original position. Now the circuit is like this without any ammeter through R3. Now I am going to measure I2 and I1. For measuring I2, I just take out from this point, connect negative of the ammeter here. The positive of the ammeter is connected here. The current is 25.04 milliamperes now. I am going to measure I1, so I am taking out at this point, connecting positive of the ammeter here. Negative of the ammeter is connected at this point. The current is 25.65 milliamperes. Current I1 is 24.97 milliamperes. Current I2 is 25.65 milliamperes. They both could be approximated to 25 milliamperes. This is a null current condition. Current through R3 is 0. The circuit is going to behave like a simple series circuit with the current from each of the sources measuring the same. After you're done with the readings for all the tables, you can do the calculations and give your values in these blank spots. To check if your values are okay, to verify your values, you need to work manually going through the steps and find the currents I1 and I2. From the currents I1 and I2, we can get I3. I3 is here. Once I3 is found, you can calculate the voltages using Ohm's law. V is I times R, right? So I1 times R1 would be the voltage across 100 ohm resistance. This is V1, V2, V3, V4 and V5. Therefore, we have used Kirchhoff's laws to find the unknown voltages and currents in a circuit that has more than one power supply. Thank you for watching. Bye.